My name is Bill Hoffman. I'm one of the founders of Kitware and the originator of the CMake project. Okay. No tomatoes, but I'm sure some people are thinking about it. But anyways, I'm going to talk about modules, C++ 20 modules, and a little bit more. First, glad to be actually in Aspen and not doing a virtual talk from my den in my house. I've got out, got a couple runs. I like doing ultramarathons. I've run 100-mile races, and maintaining a build system like CMake can actually be harder than running 100 miles. I think with the, you get a lot of opinions about CMake, whether it's good or bad, but it's all about creating a useful tool. I mean, I'm a very pragmatic person, engineer type. So I want to talk a little bit about Kitware. I'll try not to be too advertising about Kitware. But we do software development. We have about 230 employees worldwide. But most of our work is consulting. So the point of this talk is we don't sell CMake. There's no paid version of CMake. Where we make our money is basically finding collaborators and building on the CMake project and building the next new features. We work in various areas with academics, government agencies, commercial companies, medical, energy, intelligence. We have a variety of open source platforms that we've been supporting. We started with a visualization toolkit. Actually started the company, that's like 25 years old. It's a C++ based library. So we've got kind of a long engineering history of creating projects, and CMake's one of them. And we work in computer vision, data analytics, scientific computing, medical computing, and software solutions. That's where the CMake sits. For CMake, we do training, feature additions to CMake, develop, audit, build systems, port people's build systems to CMake. And we work with other companies. We've been working with NVIDIA. They've been doing some work adding stuff into CMake. They work with ParaView and some of our VTK stuff on the HPC side. This was kind of cool. An unlikely but a cool contributor was Mojang and the Minecraft group. They use CMake heavily and have contributed. Anybody here use the CMake presets? Do you like it? Yeah. You can thank Minecraft. They funded it. And Kitware implemented it. And they're also chipping in a little bit on the module side on the Visual Studio. This always sort of shocked me with CMake when Visual Studio adapted it. So I always like to say that, and I remember I told it to one Microsoft guy when we were talking to him about some work. I said, I'm pretty sure back when I started CMake, you guys would have sued me for reverse engineering your file formats. He said, no, not us at Microsoft. We're very open. I'm like, you weren't back then. You really weren't. But times have changed, and there's obviously a huge adoption of CMake at Visual Studio. And Bloomberg, which we've met through our work, it's kind of tied to this module stuff, which I'll get into. But we've been more involved in the standards committee work to protect our interests and to protect the interests of CMake and the build system community and tooling community to make sure that standards proposed will work for us and for the engineering community that use C++. They've contributed some improvements to the file-based API, and what I'm talking about now, really grateful to Bloomberg for supporting us with the C++ 20 module support. Originally, CMake came from the Insight Toolkit, this National Library of Medicine, funded Kitware to create this new toolkit. And back in 1999, early 2000, there really wasn't a cross-platform build tool. And I said, we've got to create one because I'm sick of having auto tools on Unix, a checked-in Visual Studio project for Microsoft, and maybe some guy that knows how to get it to build on Apple. We need to do better than that. And that's where the need came from, and then we created this project. We were not tasked with them with creating something like that. They just said, create a toolkit and make it work on these platforms. But it's obviously grown more. It's a big community effort. There's a lot of people outside Kitware that contribute a lot to CMake. There's some great books out there. not written by anybody at Kitware. The basic workflow of CMake, you run CMake on your project. It does a configure step. You can do CMake ---- build, specifying -J8. You can touch a CMake list file, run CMake build again. It's going to run CMake. There's GUIs to configure the cache. Most people probably already know this. CMake adapts new technologies, so developers don't have to. So as new IDEs come out, new architectures, like when Ninja came out, Google created this Ninja tool. And I think within a month, someone had it working in CMake. And suddenly, everyone that was using a CMake project, their parallel builds got way better and faster than our makefile support had been. And as new compilers come out, we follow that. So CMake, we've done a good job, I think, following and keeping up. But enter C++ modules. This sort of struck fear in the heart of the CMake group at Kitware, because we realized the enormity of it through our work with Fortran modules. So let's look at just a simple module example here. So I've got a b.cpp and a a.cpp, and export module b, and over here I'm importing module b. And if I just say CL standard 20 interface, and I try to compile a.cpp, I get an error. Why do I get an error? Because B has not yet been compiled. This is something completely new to C++. Prior to modules, it's embarrassingly parallel. You can build all the object files you want. It doesn't matter what order. You link them all together, and that's how it works. But if something exporting a module, it's got to be compiled first because the consumer needs to know about it. So if I just change it here and I compile B first, and then A, then everything works. If I look in the directory, I can see there's these IFC files, which are those exports, the build module interfaces that Visual Studio does. They have the IFC format. So built module interfaces. If you look at Bryce's paper, where he creates sort of a way, he defined a lexicon for modules, the BMIs in there. Currently, in what we have supported, Microsoft creates IFC files. GCC has .gcm files. You can look at that paper for more information on this. So CMake has actually 16 years of experience with modules, just Fortran modules. But they're very similar. So in 2005, we had the initial makefile support for modules, which made some Fortran developers very happy. I actually met developers like this, and the way they built it is they just kept typing make. make, until all the modules got built, and then it would work, and then the next time through, because there was not really a great way to capture that dependency information. So Kitware found a way to do it, but to do that, we had to add a Fortran parser into CMake. So there was actually a simple Fortran parser in CMake. So remember Ninja? We talked about Ninja, the build tool. Well, to support Fortran modules, we need to do dynamic dependencies. Because now, when CMake reads a file and gets a list of sources, it has no idea who produces what modules. So it's generated the build system, but the build system needs to dynamically change those edges to know that A depends on B, and that B has to be compiled first. So we went through a whole effort of getting that support into Ninja. And we got it in, we had it working in 2015, and it took until 2019 to get it upstreamed into Ninja. And the only reason they moved it in there was because of C++ modules. So we're kind of in this long game of trying to get C++ module support. So if you look at the Ninja manual, you can see the reference for the dynamically, dynamic dependencies. And you can see that it's saying that, essentially, information needs to dynamically be discovered from the source file content during the build in order to correctly first run, e.g. Fortran module dependencies. Unlike header dependencies, which are only needed on the second run and later to rebuild the project, right? So you could build all the files, and then as you're building them, you can generate your header file dependencies because they only matter for the second time around. Does that make sense? Second time you do a build. Incremental build, yeah.
Oh, right. Okay.
Right, so the second, you didn't make the first time, you got .o file's not there, you create it. And as a side effect, you can create the dependency rule for any header files that were included. And so it doesn't have to happen in the middle of the build. But with modules, as I'm going into the build, I've got to go in there and update my build graph for Ninja, or my build, whoever's doing the build. So CMake has a Fortran parser based off a thing called MakeDep F90. And we did these patches to Ninja and added that dynamically support. And then we have a dynamic dependency collator inside of CMake. I'll go into this a little later. But hey, we don't want to do it alone because we definitely don't want a C++ parser inside of CMake. Hands up, who wants to see a C++ parser inside of CMake? No, there's not. There was what we were doing, sort of the header file stuff to get those dependencies. But that was pretty bad. So CMake does need help from the compilers. So in 2019, like after we got over the shock of, oh my God, they're adding Fortran-like modules to C++, and we've got to support that now. But hey, that's great. We know how to do it. And we started like telling everybody, we knew, hey, this is how you do it. And people are like, what? No. I heard someone's got a build tool that works with modules. It's easy. It just works. Like, well, wait a minute. No, we had to put a lot of work into this. So anyway, so we wrote this paper describing how CMake supports Fortran modules and its applicability to C++. So you can look that article up. And essentially, Fortran modules, so if you look, have a function here. I've got my main that says use math, and this module up here that's math. So math.o, so when I compile the top file there, it produces math.o and math.mod. When I compile main.o, it needs to read math.mod. So essentially, you end up with sort of a build graph like this. I've got my input files. I pre-process them all. And then I scan them with our internal Fortran parser and figure out who produces what. So these are dynamic dependency information for each of the translation units. Then I have a collate step, which creates a dynamic dependency file that can be loaded into Ninja and tells it that, hey, these two guys can be compiled parallel, but that one's got to wait for this one to be done. And then I can, once that's done, I can create my library, because I'll have my .o files. And similarly, you're going to have to handle multiple targets for this. So pre-process scan, collate inside each one, create dynamic dependencies, and look across too, in case there's modules using, if you're using modules and other libraries in your build. All right, so we knew we needed the compilers to do that because we don't want C++ parser in CMake. So we created another paper, Ben Bokel and Brad King did, which described a format for describing dependencies of source files for use in modules. And this is a simple JSON format that is pretty much agreed upon. So where are we today? Drink. So Visual Studio 2022 preview has module scanning support for named modules. Header module support is still coming. I think it's slightly broken in Microsoft right now. And I'll get to that. I've actually got a slide for that, where I want you guys to go upvote something. And then there's a GCC patch for named modules that Ben Bakel's got. And Ben Bakel's got a working module branch of CMake. And that's kind of what I'm going to be talking about now. So Visual Studio 2022 added to CL the scan dependencies. And this produces that JSON file from that paper. So let's go back to our simple a.cpp we talked about. And let's try it out. So we do CL C++20 scan dependencies. We're going to put it into a file called a.json and compile for a.cpp. We get a version, a revision, rules. Primary output is a.obj. It outputs a.json and this a.ifc file. And it provides A, and then it gives the source path to the source of the file, and then requires B. So we'll do the same thing to B, and you can see that it's got very similar stuff. It's got these outputs, and its logical name is B. And with the on GNU, we can do the same thing. We get a similar looking file. Not quite the same, but yeah, go ahead.
Why does it output the source path?
It might need to go back to it later. I mean, it's just useful for compiling. You might need to go back and compile the BMI. And you can see that the GNU one doesn't provide it. So it was something Microsoft added. And we can see very similar output for the other one. So we've got basic support for named modules is there for Visual Studio and a patched G++. Now I'm going to take a quick segue into a new feature added in the CMake called the file set. So the file set, best to look at an example. So essentially what file set allows you to do is to create header-only libraries that are really fully functional C++ targets. So if we look at the install header-only library, before file set, we've got a set of sources. We create a library eigen interface, and then we give it the list of those header files. Target include directories. You can see I've got this build interface, which goes to the CMake source store source. An install interface, which goes to include eigen. And then I create install targets. And we install the header files. And we can create an executable and then link to that header-only library. It works. With file set, so we create a eigen library interface, then target sources. Instead of listing the sources in the library, we create target sources with the file set headers. We're saying the base store is source, and then we list out our files there. And you can see it gets in our file set. So there's no generator expressions required here. And we're able to know the install target just says include eigen. And I think people would agree that's a little cleaner. So we run CMake -- install prefix. I give it some directory right below me. I run CMake, run ninja install. You can see that it installed all the header files and then the export CMake module. back to a.cxx and b.cx with the updated file set. So if we went back to the manual page for file set as it exists before now, it said the only acceptable type was headers. But we've added some more CXX modules and CXX module internal partitions. So let's create a simple CMake project. We'll say we want C++, C++ standard 20. We create target sources with a file set, CXX modules, type CXX module files. We give it a.cpp, b.cpp. This is what, yeah.
So with this file set in CXX modules, can you mix non-module files into this library?
Yeah, sure.
Can you repeat the question?
Oh. The question is, can you mix non-module files into the file set? And yes, you can. I think I have an example of that later. But essentially, you could just say private and list regular target sources. So you could have other target sources. This is just a CXX module file set. But you could add more other target sources. So let's try to compile this. We CMake -g ninja. We get a warning that our module dynamically stuff is experimental. It might change. And build files have been written. Then let's run ninja -v. And you can see it's doing our, let's see, where are we? Right, so we're scanning dependencies for A, then B, and then it runs the collator, which is the CMake -c, CMake ninja dynamically, which reads in this file, creates a mod map file, format MSVC, and creates this dynamic dependency file that is loaded by Ninja, the cxx.dd. And it's passed in a response file. And then you can see it actually starts compiling. So right here, it's going to compile B, then A, and then we've got our build. And similarly with G++, it does pretty much the same thing. Completely different. Yeah, sure.
Is it actually faster than the old mechanism of building? Because previously this was 3 steps, now it's 6. Is there any real world performance improvement?
Well, you're able to use modules. So that
I mean, so,
before it wouldn't work at all.
but compilation process looks like the compilation process itself has a lot of back and forth. Do you get a faster, starting from 0, do you get a faster build with modules?
See, that remains to be. So modules aren't magic pixie dust. But since they are pre-compiling a lot of the files, the question was, are modules builds faster or slower than non-module builds? And it still remains to be seen how this hits the real world. And there's another question.
People at Google and Microsoft have independently tried to test this, and what they found is that when they modularized part of their code, especially like often use headers, they were getting factors faster, and then they extrapolated that. They both extrapolated to the same thing, which is if everything's a module and there's no headers, it's about 10x faster.
Did Google use named modules?
No.
No, those are header modules. So there was a comment from that said Google and Microsoft benchmarked header modules, and if everything was done with modules, it was 10 times faster. And there's a paper out on that as well, if you look for it. That,
Most races provided that talks.
yeah.
It's a lot faster.
But yeah.
I'm sorry, I'll have to question.
I think I was about done with it. Yeah, go ahead.
where's the scan dependencies in the GCC example here?
Right here, this fdep file.
So is that a.cpp.o.ddi actually that JSON file?
Yes.
Okay. Is that like, is there any thing different between the GCC output and the Visual C output? Or is just the extensions different?
The JSON, I mean, it's got, so the Microsoft had a little bit more information, but the format's the same. So. Any more questions? Or yeah?
This is a weird thing, but theoretically, does that mean that you could scan with one compiler and then build with another?
The question is, could you scan with one compiler and build with another? The answer is probably not.
Okay.
Should work.
Well, no, because when you're scanning it, I mean, one of the reasons we need the compiler to do this is because I need to see any if-def stuff or built-in stuff for that compiler. And if you use a different compiler, you might get totally different dependencies.
Also intermediate pricing and
So you're saying the preprocessor's bad?
Wait, you're saying that like a flag can change what modules you were importing? And yeah, I guess that can.
Yep.
It could, yeah.
Yeah, like if you're building on GCC, include this module. If it's MSVC, but
Yeah.
use another one.
Yeah.
Someone write that claim tidy check.
Now, name modules aren't allowed to export pound defines, but you can still have stuff in there that might change.
So seriously, someone write that claim tidy check. Yes.
Yeah.
Can't define round and import module.
Yes.
People do that.
And your graph would be different. And if you change your source, you have to rescan because that might be your graph is not different.
And that hash include could be different on Microsoft than on GCC. And then
Yes.
Yes.
Or you just had a typo. And you have to rescan and your graph is different.
I have one more question. What about Clang?
One more question is, what about Clang?
I
pretty
can
big
give you
question.
details of the claim status later.
Okay, cool.
It's not there yet.
And yeah, the answer is it's not there yet.
Are they going to plan to support the JSON stuff? Or?
Yes.
Okay, good.
If people understood.
Yeah, and we're looking forward to it being there, and we're ready to support it when it is.
And it's an open source project and people are free to contribute to the claim project.
And we may work on a patch ourselves. But where it stands today is we've got G++ and Microsoft. And again, so this is sort of the same slide that I showed for the Fortran stuff, but a little simpler. So essentially, each translation unit gets scanned, and that's done by the compiler. And then there's a collator that pulls all that together and creates this dynamic dependency that Ninja can load. So here's the chart I tried to make. By the way, this is a really cool talk for me. So like I said, I'm one of the founders of Kitware, and mostly I do pointy-haired boss stuff lately. And don't get to get in the trenches that much. But this module stuff was, I don't know, I was involved in it way back when we were doing it with Fortran, and I was afraid of what might happen if CMake fell behind. It didn't have module support, so doing this talk is sort of fun, and I went through and I'm actually built my own GCC. I'm getting the preview version of Visual Studio and trying to figure out how this stuff works. So bear with me, but I'm having a lot of fun. Maybe I should demote myself and work for one of the other founders. Some of the founders have done that, Kitware. Anyways, so at the beginning we run the CMake process. So these are processes over here, and over here are the files that are produced. So you run CMake on a project, and you get your rules.ninja and your build.ninja, and a cxx depinfo.json file per target, and that's something CMake uses to figure out dependencies in between targets. And then we run Ninja, and then Ninja sort of creates this, our compiler does a scan per unit, and that creates those JSON files described in P168.9R4. And we get the DDI files, and then CMake -e, CMake Ninja dynamically gets run per target. And a target in CMake is a library or an executable or some end built target. And then that produces the dynamically file that Ninja can load. And then for each translation unit, we get a mod map, which is essentially contains where all the BMIs are for that module, because then we can pass some of the compilers, although they can search it kind of like a include path to find the modules, you can explicitly give them a mod map and have it use that. And that's probably the safest way to go, so you don't run into some weird problem where you're, wrong include directory essentially, and picking up the wrong BMI. That doesn't. Yeah, sure.
So in the third column, you generate this so basically you call the compiler to generate this JSON file, which is going to tell you what the dependency graph is.
Right.
And the fourth step essentially is just translating that information into a format that Ninja understands. Is that correct?
Well, it's collating it all. So this one does it in parallel on all the translation units.
Oh, right. And then
The first
you get
step.
one file in the end.
Right, and then we have a collation step that pulls it all into one
That's
file.
like a Ninja specific kind of format thing, and Ninja is like the only build system that can consume something like that, or?
We haven't added it to the make files yet, but we probably will. But we got to rework the way the make files work in CMake a little bit to handle it.
And like,
But we are doing, the make files do this with on the Fortran side of things already.
But they have like a different in-depth format.
It's
So it's the same one.
yeah, it can use it. Well, it's a slightly different format, yes.
Okay, cool.
Another question.
Kind of a related question. I assume that Visual Studio, like if you're not using CMake, Visual Studio supports modules with just built into the solution and project files and stuff like that. Can you generate Visual Studio project files from CMake that support modules?
The question is, if you're using CMake and Visual Studio and you're generating Visual Studio projects, how does Visual Studio support modules? And yes, Visual Studio supports modules. Actually doing they pretty much copied what we did here, as far as I can tell. They're using the same thing with MS Build. But you still need to mark them as modules because they need to know that these things are modules. So essentially going back to that file set, that allows CMake to tag it. Even if we're generating a Visual Studio and we're not doing any of the build stuff here, we still need to tell Visual Studio what types of files they are. So if you went through the IDE and you said, if you look at their examples, they'll say like create C++ module interface. And then they're tagging that file as, or you can use their special extensions they've got on the source files. So, yes, does that answer the question? And CMake also creates a cxx modules.json, which is a CMake readable version of the dynamically file, so that CMake can go into other targets and figure out cross-target module dependencies. And then finally, you once the build graph has been updated, you can go do your parallel build and build all your .o files and libraries and executables just like you used to. So a little bit into named modules. So a module unit is a translation unit that contains a module declaration. A named module is the collection of module units with the same module name. A module interface unit is a module whose module declaration starts with the export keyword. Any other module unit is a module implementation unit. A module partition is a module unit whose module declaration contains a module partition. So I went, being the pointy-haired boss guy, I'm like, all right, I'm going to go C++ standard. I'm going to look up module partition, and I found this example in here with a translation unit 1, 2, 3, and 4, where this essentially is the primary module interface, a module partition, which is a module interface unit forming the interface, a module partition internals, which does not contribute to the external interface. Anyways, I typed this code in and went and tried it with Ben's stuff. So I All right, here we go. I'm going to create my target sources. And here's essentially, so T4 is just a regular, that's where the main is or whatever. And it's not a module file. So this is an example of how you would have a non-module file plus modules. So I've got a file set, modules, and I create an executable. And it works. We did a build with G++, and everything worked. Cool, I'm happy. And I went in with MSVC, and whoop, I got an error. CMake said that T3.cxx is of type CXX modules, but it did not provide a module. Anyone tell me what happened here?
Is that the one that's an internal partition?
Yes. So Microsoft added, their interpretation of the standard, they added essentially for internal partitions, when you have, so GCC sees one of those and it essentially does the right thing. It's whether it produces a module that BMI or not. And Microsoft by default sees it as an implementation thing and it does not produce a BMI. So then we get the error. But we can fix that with our type CXX module internal partition. Yes?
Do they need a separate command line flag to generate a BMI from that kind of file?
I do.
I think that's a bug. I view that as a bug.
Well, so if you go on the SG15 mailing list, there's a thread with like 200 emails or something arguing that point. So it is what it is today, but that CMake's sort of an engineering approach to the world. We can't dictate what is or what isn't. We have to live with it. But
And quick clarification.
yeah, sure.
Does this work for GCC, G++?
The question is, does this work for G++? The answer, the internal markup, yes, it does. Because it doesn't care. Yeah.
Are they just semantically the same for GCC?
Yeah. So we'll run Ninja again, and voila, we get scanning for dependencies. You can see our dynamically step, and then we start building our object files. We create a static library, and then we generate a dynamically file for the main, and link our executable. Yay, everybody's happy. So let's, what would happen if we had this in two different libraries? So if we made a t3.lib, and then our standard module, essentially pulling that internal partition into a separate library. And you can see that's fine as well. It all works across different targets. Yeah?
Do you get parallelism between targets? Like, I actually missed the previous slide, but I assume it had like a target link library.
Yeah.
Yeah. Okay. Yeah. And so do you actually get parallelism there, or well, I guess here you wouldn't because just you have an absolute dependency. But like in theory, if you had enough available parallelism, would you actually get it?
You could get the scanning part. Yeah. Could do.
But would it actually start building or start scanning? I guess the main target while the library it depends on is being scanned too.
Yes, it could do that. Yeah. Have another question.
For parallel builds, I don't know if this is something that CMake would solve or the build system would solve. Does it prioritize or can it prioritize targets that are more likely to be more immediately needed? For example, like if you have one file that's, you have like a large chain of them and then one module that's only used by the end executable, will it like delay that last one if it's low on threads?
Probably not.
Okay.
I think Ninja looks at the whatever that's called, the longest path, the critical path. I think it looks at that.
But it's definitely at the Ninja level.
Yeah. yeah, the question was, does the build tool look for the, essentially try to build the thing?
Well, yeah, we'll prioritize the longest path.
Will it prioritize the longest path? And I think Ninja does that, yeah.
Okay.
As long as you create the files correctly. But obviously, yeah, there are some bottlenecks here, right? We've taken some parallelism away by supporting modules, but that's just what it's going to be. I mean, there's other folks that say, oh, the compiler should do this. It shouldn't be the build system. And the way the compiler would do that would be, so when you go to compile that A.C and it sees that import B, the compiler says, all right, well, I'm going to suspend this process, and then I'm going to go off and wait until B shows up. And then when that finishes, it'll come back. But if that's really deep, that could suck up a lot of memory or whatever and cause its own problems.
It's terrible. That's what Clang does today.
All right, so at Kitware, Brad King, who's been working on this, when he wanted to dig into modules, he created an example here, and I'll sort of walk through it. It's very similar to what we just did, but so it's got a main that consumes some modules, a my module, which is the module interface unit, a implementation unit, and then a partition, which is re-exported by my module, and then a module partition implementation unit, and then the internal module partition. So we've got our main here, and we say import my module, and then we call a bunch of functions that were exported from that module. And then in my module CPP, I'm saying export module my module. I'm doing an export import of this partition. I'm importing the partition internal, so I can use that, but it's not re-exporting it. I'm exporting a function from this module and implementing it right here. The implementation can use internal module partitions, even though they're not exported. So it's pulling a function from there. And I'm exporting a function of this module implemented elsewhere. Here's a module implementation, implementing a function declared in the module interface unit, implementing another function declared in the module partition. Now I'm I've got a module partition which exports this partition, which can only be imported by the main module. I'm exporting a function from this module partition, implementing it here. I'm exporting a function from the module, but I'm implementing them elsewhere. All right, here's where the fun Microsoft stuff comes in. So here I'm saying module, my module, partition. And you need to compile this without using the minus internal partition flag. Else you just say module, my module. And then I'm implementing the function there.
On that previous slide,
Sure.
does the compiler actually accept that?
Yeah.
Because that's not valid.
Which?
Having a if-def up there is actually part of the grammar you can't.
Yeah, it has to be the first statement in the module.
Yeah.
It has to be literally the first line. You don't need a white space before it.
Or comments.
Or comments.
Yeah.
That is true. You know that? We'll have to fix this example. But right now it's accepting it.
Interesting. Okay.
Good point. So yeah, question from the audience was, is the if-def allowed to be used in the module like this? And it is not. Good point.
Isn't if-def a statement at all?
It's complicated.
Yeah.
Should be. Okay. Regardless of what the standard says, is that something that has to be implemented? Like, should the compiler support that?
That syntax, it explicitly should not. Like I wrote the paper that makes that not valid.
But he just said it's required.
No, it's not required. So you could write this code. This was just Brad trying to figure out how it worked either way.
Yeah, I see this is just like I'm debugging and testing.
Yes,
things.
it was a debugging and testing thing.
Yeah.
So like
But I can explain in detail later.
So scan dashboards.
Yeah. So yeah, right. So here's an internal module partition. It's a module partition that can be imported within the module itself, but not exported from it. With MSVC, you have to compile it with this internal partition flag. What I wish is they had put the flag on the other way, which was their sort of special thing, because this is what the standard says should happen, but you need the special flag for it. So if they'd done it the other way around, then you could just, if you were doing the Microsoft thing, you could just mark that. But you kind of, if you're doing it the standard way, you have to use this flag. So, but I think that that horse may have left the barn, so we may have to live with this one. I don't know. It is still Visual Studio Preview. So the CMake code for this. So I've got target sources, and then the see my module implementation, partition implementation, and main. Those are not CXX modules. They're not exporting. They're not creating BMIs. So I just list them in the regular list of sources. Getting back to a question that was there earlier. And then I've got my CXX modules with the module part, my module, and then the internal module partition.
Does the internal partition need to be public? Because I don't actually know what private and public sources mean in CMake, but it just surprises me that it's public.
The question is, does the internal partition need to be public? I believe the answer would be no, but it's just.
The answer is yes, because the module partition still needs to be visible for someone parsing the module.
That's true.
Yeah, sorry, that's true.
So the answer is yes, because it's still.
Still your parsing.
Yeah. All right.
During the scanning dependencies part, where it's building the dependency graph, can it not figure out whether a given component is a internal module partition and automatically inform CMake to use the
Okay, so
partition flag?
the trick is there's absolutely no syntactic difference between the code in the way Microsoft's defined it. So that the files look identical. It's just, right, it's like when I tried to do it, it, like I said, it went through and it compiled with G++ because it just works. So there's no way to tell because they've basically said, when you look at the files, they're the same. You could use the same file and you add the flag and it does something different.
Even though the module declaration is different.
No, I mean you could even if you had that module partition declaration, it looks the same. It can be interpreted two different ways
By MSVC.
by MSVC.
Oh, okay, yeah.
Yeah.
So when targeting MSVC, can it not add the dash flag for us? Why do we have to tell it that this file is an internal module partition?
Because we don't know what it was intended. Because the syntax can work as an internal partition or not.
You have to do this file set here, and then CMake does have the flag in both times.
CMake can't tell you. In the context of Microsoft, CMake can't tell that either.
Right.
Right.
You have to have the module internal partitions files.
Right. So something has to disambiguate, and because nobody else does, the user has to do it in the CMake list.
So the C++ source code itself does not distinguish.
Yes.
Okay.
That's the
According
problem.
to Microsoft's
Yeah,
interpretation.
the source code, but the source code does.
No, the source code doesn't. Source code.
The source code would have if Microsoft hadn't invented the difference between like the dash internal partition option for MSVC.
Yes, but like if you ignore the Microsoft compiler and you just look at the source code,
Yes.
you can tell which one it is.
Yes.
If it
But
doesn't
if-
have an
but-
export, then it's an implementation partition.
But I think with an internal partition,
Confusing partitions with implementation units. What we're talking here, like all of those are interface partitions, right? So they all have exports.
Not my module part internal. That does not have an export. See,
Right.
just looking at that one line, the second line, you know that this is an internal partition. That's the only thing you need to see, you know.
Right, but it still needs to create the BMI file because it needs to be imported by
Yeah.
the module.
Yeah.
Right, and Microsoft requires a flag for that BMI to get created.
Yeah. Okay. Yeah.
But if you stuck this into G++, it could be that you're trying to do just an implementation here, right?
That'd be weird because you have a module partition declaration.
But you're trying to implement that module partition, right?
It doesn't have export module partition.
This is always the same thing as like a private header. If you have a partition, you are equivalent to a private header. If you wanted to not have a BMI, you would just drop the colon part.
All right. I think we should definitely go outside after the talk and hash this out.
Yeah.
Yeah. I agree. I mean, it's confusing, and it.
We should co-sign a response on that big thread.
Yes.
Yeah.
The C++ now position.
Yeah. I would love to see it go away. I mean,
Yeah.
I definitely don't like that this exists. But I suppose if you weren't doing internal module partitions, it wouldn't affect you. But there is some advantage to it being marked up in the CMake files like that when you go to export the targets and do other stuff, CMake will know more about what's there, right? And also, working with Visual Studio IDE, we'll be able to tag the things as the correct types, regardless of extension. So there are some benefits to the file sets. So the CMake code, yeah, we were already on that slide. I just went back. And then we can add install and export code. So I'm exporting with named modules, which is our library. And I'm giving it a destination bin for the runtime, lib for development, creating a library. And I've got my file set CXX modules, which get installed into CXX module examples. And then CXX module BMI destination, I'm saying it's lib, CXX compiler ID, version, compiler config, so we debug, release, whatever. You don't want to mix those up. And then I create a export target, which is CMake's way of passing targets to different copies of CMake. Brett and Bloomberg, they're going to be talking about that in their talk tomorrow, which should be lots of fun to talk about.
Is there a default for the CXX modules BMI destination?
I don't know right now, but there could be.
But the paper being discussed is precisely because of that ugly line.
Which are the one I'm
Identifying the compatibility of BMIs.
Yeah, okay. Well, also the export stuff.
So let's run install and see what that did. You can see it installs the .a library and installs the module files, creates this CMake module target, and then and you can see here it's installing the BMI files underneath lib GNU 12.10. Questions on this? Let's try the same thing with Visual Studio. And you can see it does something pretty similar, except it's got IFC files. So, where are we with this? There's some cleanups required, various name module features. Header units are stubbed out, but not yet working, mostly due to lack of compiler support. So, I saw Bryce at Meeting C++ 2019, modules are coming. And then he ended it with modules are a team effort, thanks to everyone involved. And I would have to agree that this is a team effort and a long-term project. I mean, you can see this is something that I've been worried about trying to figure out how to fund, how to actually implement, and we knew it was going to be a lot of work, and kind of excited to see it actually happening. I know it's got some rough edges now, but so this is apparently this is to do with header units, and there's only 3 votes right now. It just came out like a couple days ago, but this is something Ben found when he was working on adding header units that it's got an issue with if-def defined stuff not working correctly in the Microsoft compiler. So go upvote that, and we'll try to get him to fix it. I'm going to talk about some other new CMake features. Any other questions on module stuff? Yeah.
So what if you take one of those translation units and make that file compile in C++ 11 mode? Or I guess, sorry, that wouldn't work. If you did something weird with the arguments that made the compiler not accept the BMI. Like if you change let's say you change the type of, yeah, sure, 23. One's 20 and one's 23.
Yeah.
That works because they both have modules.
So can you repeat that one more time?
So you,
Set the CXX standard on executable 23. What happens?
Seems like
yeah, the library is compiled with 20 and the executable is compiled with C++ 23.
So the question is, if the library is compiled with 20 and the executable is compiled with C++ 23, what would happen? And it would more than likely fail. Yeah, the compiler would probably start complaining about the incompatibility.
You just have to have you have to be compatible. You have like.
Yeah, well, it's kind of like saying, what if I compiled one object file with 23 and one, and then
Well, but that works.
that doesn't.
It works.
Yeah, so all right.
That's a
So the
feature now.
BMI,
That usually works.
the surface of compatibility of the BMI file is substantially narrower than the surface of compatibility of ABI. And so we need a mechanism for the build system and the compilers to successfully communicate what that surface is, which is the paper that I submitted recently and is the subject of the 100 message thread.
Okay.
Or to rephrase it, we were cheating a lot before, and it happened to work, and now the compiler's going to say, that doesn't actually work. And
It's not the same thing.
no, it is, because you can't use C++ 20 and C++ 23 in general. A lot of times you can't.
So the
Because
committee
people
has
use-
gone through
because
great
people
lengths
use-
to make that work.
What?
The committee's gone through great lengths to make that
No,
work.
no, in practice, we use feature detection, and they have APIs that are different. And that's outside the standard library. So at the standard library level, I agree with you, but right above it, it goes out the window.
Yeah, true.
Right, so in general, like this, you have to have a consistent standard flag across all the people that are consuming the same BMI, if that BMI uses feature detection, which who
But
knows?
it's still different though. If you don't have any macro guarded code in your sources, you can build a 23 and 20 and mix and match, and that's going to
No,
work.
I said feature
But-
detection does not
okay.
involve macros though.
Feature detection is based on macros. You're using the preprocessor on feature detection. But anyway, so even if that works for you, even if you have a code base where that works, the BMI is likely to change from one version to the
Yes.
next. That is not something that anyone cares about API compatibility for.
Yes.
You can use schema-based feature detection, you don't have to use that.
In any case, we should not try to solve that question here because it's going to take.
The point is, it's really messy, it's messier than we think. I appreciate all the work people put in the standard library, but it goes out the window at any kind of scale of like, even like 2012 projects or something.
I think Sean's got a new question, or?
What else has to change in the ecosystem before you remove the experimental message warning us off using this, and everyone can use this as production?
So the question is, what has to change before this can become non-experimental?
Not just within CMake, but the whole ecosystem.
Within the whole ecosystem, not just CMake. Well, obviously, yeah, CMake needs to be completely developed out. I mean, there's still a few edge cases. But I think the compiler support needs to be there. I mean, right now we've got GCC works with a patch that's sitting on Ben Bakel's, GitHub, and Microsoft's working pretty good for named modules. So, and Apple Clang is not at the party yet.
Are you leaving some time for the names to settle on the? I assume it's still in scope to rename some of those flags and some of the commands and stuff. Right?
That is actually one of the things in the thread.
Right.
Gabby cares very much about that.
So there's some feedback on some of the nouns in the CMake lists. Right? Through those.
Sure, yeah. But yeah, I'd say it's pretty beta right now. I mean, it's basically for compiler developers to play with. Question over here.
How does this work with CMake when it's outputting compiler commands?
The question is, how does this work with CMake outputting compiler commands? My guess is it probably hasn't been implemented yet, or
Probably
But
would.
there
That probably
is-
would if what you want to do is run claim tidy and build with G++, right? Unless the flags are always compatible.
It's very likely that we will need an entirely new file to describe the entire graph of modules involved in this, such that plain tidy can go and parse the code that was being built with GCC.
We need people to jump into SG15 and write papers on that.
Yep. I'm just thinking compiler commands is listing each individual file, but modules are like a separate build step before that.
Yeah.
There's no sense of like dependencies. So.
It is incomplete, we know.
well, no. It's I guess just the order matters, right? So that when CMake outputs the compile commands, they should all still show up. So I kind of take it back. It'll probably work, but they wouldn't necessarily work in order if you exported all the compile commands, and then you tried to run them without any of that dependency information.
Yeah, let me put it this way.
You wouldn't be able to get-
that we, like folks in the static analysis field, don't have to reverse engineer all compile commands to assemble a new build system.
Claim tidy is going to need part of the build system if we use the compile commands that JSON is currently running. We need a paper on it, basically. If the paper is very convincing that it's fine, then we will all be happy and approve the paper.
Sean had a question.
Yeah, you mentioned the GCC 12 fork with the dependency scanner in it. In that fork, are we also going to see maybe the name module for lib standard C++?
So the question is, in the fork for GCC, are we going to see the name module for STD?
Yeah.
Not from Kitware. I mean, it's open source. If you want to add to the patch, you can. You can but we have no plans to do that, if that's the question. Yes, Brett.
Yeah, as far as finalizing taking out a beta, to add to Sean's question, a sub-question, is the makefile support going to be important for that beta status to be removed?
The question is the makefile support going to be important for the beta status to be removed? My take would be probably not, but it shouldn't be too far off. Because like I said, we've been doing it for Fortran, but right now we've just been focusing on Ninja because that's mostly what people use. Any other questions on modules? All right. I guess I got time to go through a few CMake features then. So this one you saw me use in one of the examples. We added a couple of command line shortcuts improvements. So you can say CMake ---- install prefix, give it a path over the old way of doing it with the -d install prefix equals path. Same thing with the toolchain file. We added better debugging for find package calls. So you can say CMake debug find package XYZ, and it'll run for it, and it'll say that it failed considering the following paths and things like that to make it easier to debug when CMake can't find stuff. So you can see running with a debug might give you find library was called with the following settings. Find library considered the following locations. The item was not found. The dep file. So this is on custom commands in CMake. So this essentially allows you to, you could add your own language now through CMake. So you can do, prior to this, you couldn't do dependencies on custom commands. So it's kind of like if you had your own language that did pound include or something, or some sort of including, being able to trace those dependencies, you can add a scanner in. And this is now supported on all the major platforms, even Visual Studio. Oh yeah, this one's cool. Install with runtime dependency set, which essentially does, if you have like, say you have some executable that links to like Qt or something like that, it'll do like LDD on it and find all the libraries that it's linking. The ones that aren't built with CMake, it can pull them in and install them next to it. And it works cross-platform. It'll work on Mac, Windows, and Linux, using different tools for tracing down the runtime dependencies of an already linked library. We have a question?
Can that also copy runtime dependencies into the build tree, or only for the install step?
The question is, can it install it in? Can it pull it into the build tree, or only for the install step? For the install command, that's only for the install. But in implementing that, we added previously a file get runtime dependencies command, so you could use that to do it inside the build tree. Few other question.
On the previous one, does it rewrite our paths of the shared objects that are copied?
The question is, does it rewrite the R path of the objects that are copied? And the answer is yes. So essentially, sort of the history of this is we had something, it's like, I can't remember what it's called now. Like get runtime dependency. It was a CMake module in the CMake, written in the CMake language that did this. And it got painfully slow for really large libraries. So painfully slow that at Kitware, the group that does pair review wrote a Python script that did it because they couldn't take the CMake version, which just kills me. But they did that instead of like adding it to CMake, which would have been really cool. But they didn't. They wrote a Python script, and that's what they started using to package their stuff. But that kind of drove me nuts, and I was looking for someone to support this feature, and eventually I found someone to get it supported and get it implemented into CMake. But that was another multi-year effort to get that fixed and get it implemented in C++ code and have it be really efficient. It's faster than the Python version now. So. Few more of the CMake build type and configuration types. You can set environment variables to set defaults for them. Support for system include directories with MSVC external.
That's still broken in MSVC, right?
No, it's fixed now.
Really?
Yeah. C-test and gain environment modification. Test property to modify the environment for individual tests. The HIP language support. There's some open portability issues, but we've got native HIP language. CUDA language support has improved in several areas. If you look at the 323 release notes. Visual Studio .NET SDK style C# projects are in there, and Visual Studio NuGet package restoration with CMake -+ build. To remind people always complain about documentation. No matter how much you have out there, there's never enough, or it's bad documentation. But we've got the guides and the tutorials, and we actually are testing that code, which was kind of a requirement because we wrote these tutorials and then we stuck them in a book, and then a year later none of them work anymore. So this makes sure that the code can actually be pulled out of the documentation and made as part of the CMake testing process. So all those guides, any code you see in there is pretty much guaranteed to work with that version of CMake. We open sourced the CMake book. We're still working on revising it, but we're working on that. Should have a new version out probably a couple months. the future I would like to see. This is sort of the same slide I used a year ago in the virtual conference that we did here. I'd still want to see all the compilers providing the build system interfaces to collect C++ modules. And then the cross-platform standard for information found in CMake config files. And again, Brett is going to be talking about that tomorrow. We can talk about that, but
What do you mean by that? Is this like the toolchain files, or what's actually in the config files?
so this is like yeah, pkg-config sort of type files.
Okay.
So it's like the information, like where is it on disk? Is it a debug? Is it a release? What header files does it use? All that information, that metadata around a library so that it can be consumed by somebody.
Okay.
So right now we've got CMake files that do that. And that's caused some problems. I mean, when Qt used to, they used to write CMake files with their build system so that CMake could consume them.
Build system generator.
Yeah. But I think this we could come up with a format that's agnostic to the build system and describes a library so that it could be consumed by any build system and make it portable and work across platforms. And I think that would be a really great thing for C++ to have. Got a hand up over here?
Yeah, I just heard pkg-config. So am I the only one who believes that the pkg-config support in CMake is not the easiest to work with, let's put it that way?
The question is, am I the only one who believes that pkg support in CMake is not the easiest to work with? Yeah, you're probably not. I mean, it's not ideal. And what we're talking about here is trying to fix that.
There's a merge request. There's a merge request on the repo for that, but we should probably get some consensus before we get too far ahead on that.
Because I ended up patching that with a few hundred lines of CMake code, patching the targets that CMake creates.
We have our own implementation also we can talk later.
So cool, yeah. And yeah, thanks. I think that's the end of the talk.
Do you have a hash embed scanner to look for dependencies?
Do we, a what?
The hash embed, it's like, I think it was put in the next C version of the include binary file, like, been put into the rank.
Oh, the pre-processor command pound embed, which embeds a text file into
And
Any file, yeah.
What's the question about that?
You have a scanner to detect those dependencies.
Well, but so
The compiler should do that, right?
Yeah, those should just show up in the .d, like as part of the normal.
Yeah. Those dash M flags.
That's why they don't want a parser.
That's what it
They
is.
don't have to care about that.
Right.
yeah, so yeah, the question is, can we handle pound embed? And the answer is, as long as the compiler does, we can, because we use compiler -m to get dependencies. Because we don't want to get into the business of parsing C++, because why would we? It is. Got a question in the back?
So if I understood correctly, the compilation steps are no longer embarrassingly parallel, but is the scan dependency graph generation part actually still embarrassingly parallel? Because you can run the scan dependencies command on each file in parallel, and then it gets aggregated at the end. So is that part still embarrassingly parallel?
The question is whether the scan dependencies is still embarrassingly parallel, or is it embarrassingly parallel? And the answer is yes, yeah. Brett?
Have you, I'm sure the answer is no, but I'm going to ask anyway. Have you tried using any Ccache with any of your examples to see how cache friendly this stuff is?
The question is, have we tried using Ccache with any examples?
CMake has a very nice Ccache integration. Right?
And CMake does have a Ccache interface. And no, I barely got this stuff working for this talk, so I have not tried it. And not many people are using it. I mean, I think myself, Ben, and Brad are probably the only ones that have played around with this too much yet. But again, it's exciting to see it, and thanks for the support. And looking forward to 5 years from now when all this module stuff's behind us, and we can invent a new problem to cause us to lose sleep at night. All right, I think I'm actually done. Done. Thank you.